This is informed decisions and design through interactive mixed reality. And so we start off with the why. Why is this important? And so this is from Google. This is Tilt Brush. And the concept of this application is VR in VR. So you're in a virtual reality environment, building a virtual reality environment. And so this took me 30 minutes to make, and it was my first day in Tilt Brush. And to me, what was really amazing about that was the intuitive nature of the application. It was easy to learn, easy to understand, and it was an extension of my hand. And so to me, I think this is an idea to bring into Stantec, because we have so many diverse and interesting businesses that happen in the umbrella of Stantec. We just don't have a very good way of bringing that to other people to kind of have that cross-application of knowledge. So when we talk about how these applications work, this is visual scripting for a space layout generator and Dynamo. So it's a lot of words, but ultimately each node is just representing an action. So every time you click in an interface, that's how I'm capturing the node. And so in each of those actions, I can capture any approach. I can capture design thinking. And so in that, we can start to look at architecture and engineering and how we can kind of bring the two together with similar actions. So we've achieved a lot in this. I've only been with Stantec 2.5 years, but I've been a part of 7 CNIs. And so in each of them, we've explored advanced visualization through virtual reality, augmented reality, computation, and building mobile applications. But so when we talk about the gains from those endeavors, I think it's best explained by this artist, Michael Hainmeyer. And so what he's done is look at permutations of an algorithm where he's trying to recreate classical Greek architecture, but he's letting the computer be the thing that constrains him. And so then he goes straight into additive manufacturing, and he makes a room. And so to me, that kind of represents a beautiful idea of integrated design manufacturing. And so when we talk about computation, these are usually the words that come up. Is it a sexy facade? Is it digitally fabricated? Is it some kind of crazy form? And to me, that's not the most valuable thing in computation. The most valuable thing in computation is capturing design bias. So what's your approach? What's your thinking? What's your logic as you start a project? So there's a lot of terminology that you'll hear me kind of talk about, and we'll go through each one of these, but ultimately the one I want you to walk away with today is metadata. That's the most important aspect and a cornerstone of computation. You have to have appended information that you can index and then that you can leverage and search against. So that, as we look at kind of parametric modeling, this was the first tutorial I took to learn how to use Grasshopper. And this is called the Twisty Tower. This video is about 10 years old. But ultimately, it beautifully captures how the nodes operate and how you can put on a simple change that then affects the entirety of a building. So the nodes each generate kind of a different genesis to that shape. But if we evolve that into a mature thing like we're doing here, this is Project Fractal, it's the same approach, except now I'm looking at generative application of parametric modeling. Every space that I have in a parametric range, I'm now capturing and representing with parallel coordinates. So this was a proposal that I worked on for Toronto, but it brings up this question whenever clients ask, what's more important, geometric manipulation or data-driven design? Data-driven design to me is king because that can control geometry, and more importantly, what it can do is validate your approach. It can validate why you're going in the direction that you're going. So you can correlate demographic information or psychographic information from Esri. So now let's talk about what's rule-based design. And so this is a case study I did a year ago for the BC social housing development. And so the housing development dictates what size a room is and what kind of adjacencies rooms must have to make units and how units can come together to make floors. Now, the only difference between this slide and this slide is that it's a level of fidelity. So all we were looking at before was the outline of the room, and here we're looking at what generates the room and what are the mechanics behind that. So linear length of the kitchen, furniture that has to be placed in each room. This is no more than a sketch, because all I'm doing is it has to fit this, and then it has to be this kind of parameter. So ultimately, this is just a fancier BIM, right? Because I have all this information, I can go through materiality discussion, I can talk about design options, but I have the data. I have what I need to do to prove that it's a good idea. So to me, as we push this forward, rule-based design can do a lot of project generation. It's your first sketch, it's your first thing of what's possible. Now, this has already been talked about a couple of times, but in this example, we have a simple cube with a 6x6 panel on 4 faces. The amount of permutations that can happen just from looking at 2 panelization studies is in the billions. So you have to have design bias to constrain it down and make it something that a computer can compute. So late last year, Lee Sedol, the world's best Go player, played AlphaGo and lost. And so in the second game, AlphaGo did a move that was unexpected to the world, now known as move 46. And so it was a 1 in 10,000 odds the computer would play it. What was more interesting is that after Lisadil lost, he said one more game, and he beat AlphaGo, and he beat it with move 77. And so when we talk about how that happened, Lisadil made a move that changed the orthodox of Go, a 5,000-year-old game, and it happened by Go looking backwards. All games that have ever been played, all moves that have ever happened, what makes a good move? So you look backwards to look forward. And I think if we do the same thing at Stantec, we can have cross-contextual learning and application of all of our disciplines. We all do a lot of things where you have overlap. So statistical analysis, or program validation, or making intelligent use of forms and capturing information from others' opinions. So this really leads into what is data visualization. And so for me, AR, VR, MR, real, it's all the same because all I'm really looking at doing is visualizing something that's complex. So it's a lot of data, it's a lot of information, but I want to make it simple and I want to make it easy to understand. So this is where a lot of the focus of my creativity and innovation work has been. But ultimately, my favorite form of virtual reality is phone-based. So I can send you a text message. You can receive the message and look at virtual reality on your own phone. It's instant access. So that doesn't require you to come in, wear a fancy headset. You can use your device, and you can be anywhere in the world. And then you can text me back, like, I like this option. That's a really valuable interaction. The other thing that I really like is real-time renderings. This is Enscape, and this was on a building out of Calgary. But the thing that's really interesting about this is this model wasn't intended to be visualized. That's a construction drawing model right from a Revit production team. And then we just ran it on Enscape to see how good it would look. And I was really impressed. So this, to me, is a huge thing about leveraging that same information, the same thing that we're using to make our construction documents, we're going to use to make our renderings. Now, an even faster way in the virtual reality is taking a sketch and using Pano to VR and spherizing it. So now you can be immersed in a hand sketch. This now represents the quickest way into VR, and you can still access it on your phone. So to me, it's a version of how quick can we get there and how much can we leverage of what we're already doing. So truth is, when we try to make packages of software, it is really complicated. Each package, each thing has its own niche experts, and each piece of software does one thing better than everything else. So earlier this year, I participated in an AEC hackathon, and I was with a great team of hackers where we looked at taking a Revit model of a hospital and then simulating a user meeting. We're going to capture all of the verbal comments of the virtual walkthrough. So this required geolocating them in the model. It required transcripting their audio. But ultimately, all of this complexity got simplified when we just made a really nice, elegant dashboard that showed here's where people walked, here's where they stopped, and here's where they made comments. And it's interactive. So you can learn from that dashboard by clicking on different things, seeing what they were looking at. In this example, this is an RFI dashboard. So request for information is something we all have to deal with if our project goes to construction. Oftentimes, we actually can't visualize that. It's stuck. It's dumb data. So we're looking at making it intelligent data, a smart PDF form, just fields that are recognized that can be indexed in a database. And this is ultimately how I want to structure the investment from my efforts with the corporate side of Stantec, with the innovative technology development team. We want to look at things that we all do, places where we can all benefit, and then find that margin, find that value, and then make a solution for it. So this is a group that's been under Peter Salisbury at the moment, and I'm looking at lots of different things with computation, advanced visualization, but ultimately bringing those two things together. So we have reactive scripting to you in a virtual reality environment. It goes back to that tilt brush thing. How easy can I make the access for you? How easy can I make that computation effort for you? So this is one of my favorite pictures because that is a ultra short throw projection monitor on top of a 70s model drafting board. But it represents what I'm really after. Old legacy actions with really intelligent features. So in this way, we're doing red lines that are vectorized. So it's not ink on paper that I have to scan and then store on a network. It's a vector on a cloud-hosted sheet that I can then share and task delegate to anyone. So it's advanced computation skills or advanced computation tools that are made accessible and simple. That's the real heart of the charter that I'm a part of. So as we move this forward, and as we're looking at different things that we can do to kind of solve these bigger problems for Stantec, it's looking at leveraging our relationship with Autodesk and Microsoft and how we can bring complex things together and leverage our relationships with our partners. One of the things that we've done in the charter this year is look at the hierarchical relationships of everyone at Stantec. So in this slide, at each pixel is a person. So that's 23,000 people that all have something that they can teach me, and I'm sure they all have something they can teach you. So we're looking at ways we can make tools that are simple and easy to use and leverage our most valuable thing, which is our stored institutional knowledge across all 23,000 people, because that's truly what will make big value. Thanks.